solve systems of equations by graphing. We found where the lines intersected. That point was what we call our solution. We're going to learn a different method today, and that's called substitution. There is another way to solve algebraically, and that's with elimination. And there's going to be times when substitution definitely works better, and there's going to be other times where elimination is going to work better. At this point, my goal for you is to solve by substitution. Guys, if you're working on something else, I need you to put it away and get out your notes, please, so we can focus on today's lesson. So, like I said, there's two ways to solve a system of equation algebraically. That is through substitution or through elimination. Both of these methods are methods that you learned in Algebra 1. Here's kind of a quick three-step process for using the substitution method. Number one, we need to solve one of the equations for one variable. We have to have a variable by itself in order to use this method. It won't work unless you do. Step two, substitute the resulting equation into the other equation for the variable. So we're going to take that equation that's solved for a variable, we're going to plug that into the other equation. At that point, we'll have one variable in our equation. We'll solve for that variable. Once we have that answer, like 6, whatever x is, it could be 6, 7, it could be any number, we're going to plug it back into the other equation to solve for the other variable. So here's our first example. Y equals x minus 3. And 2x plus y equals 3. We can solve lots of equations, but you cannot solve an equation. You can't find an answer unless you have one variable left. We have two variables in each of these equations, so we can't solve like we normally do. So we're going to use a method called substitution, where we're going to use one equation to help us solve the other equation. So in step one of the methods, I said that you should have one equation that solves for a variable. We do. The first equation is solved for y. So I'm going to take what y equals, which is x minus 3, and I'm going to put it in for y in the other equation. So now I have this. At this point, you should have an equation with only one variable. I only have x's in the equation. Now I can solve. If I had an x and a y, I could have solved. There's nothing to distribute, so I'm going to combine like terms. 2x plus x is 3x minus 3 equals 3. Add 3 to the other side. And then I'll divide by 3. So x is 2. My answer is still going to be an ordered pair. I know the first value of that ordered pair is 2. Now I should find the second value. So I'm going to take 2 and I'm going to put it back up into, it doesn't matter which equation. I'm going to use the first equation. And now I'll solve for y. 2 minus 3 is negative 1. Like we said, our solution is going to be an ordered pair, 2, comma, negative 1. We can easily check our answer to be sure that it's a solution. Remember, if an ordered pair, if a number is a solution, then it works, and we plug it back in. So if I put this ordered pair back into the original equations, it should work. So I'm going to put 2 for x and put negative 1 in for y. So negative 1 equals 2 minus 3. 2 minus 3 is negative 1. It worked. It was equal on both sides when I plugged it back in, so I know that it worked for the first equation. Now let's write the second equation. 2 minus y equals 3. Whoops. So y there should have been 1. That ordered pair worked when I plugged it into the second equation as well. So I know that this ordered pair is in fact the solution. Look at the second one. We have y equals x plus 5 and x plus y equals 11. We could graph this. Okay? We can always solve by graphing. You can use substitution, you can use elimination. We're using substitution today, so we need to have one variable by itself. Do we have a variable by itself? Sure, the first equation has y by itself. So I'm going to take x minus 5 and I'm going to put it in for y in the other equation. At this point, we should have an equation with only one variable. We only have x's, so we should be able to solve. There's nothing to distribute, so I'll combine my like terms. X plus x is 2x plus 5 equals 11. I'm going to subtract 5 from both sides. 11 minus 5 is 6. Divide by 2. 6 divided by 2 is 3. Now we're going to take our answer of 3 and substitute it back up into one of the equations. It does not matter which equation you pick. I'm going to use the first one again. Y is 8. Remember, your solution is an ordered pair. It's 3, 8. It's x, y, so 3, 8. Once again, you can check your ordered pair to be sure that it is going to work. Be sure that it is the right answer. So if I put 8 in for y, it's 8 equals 3 plus 5. Of course, 8 equals 8. That worked out, so I know that this ordered pair works for the first equation. Put into the second equation, 3 plus 5 equals 11. Of course, 11 equals 11, so it worked for the second equation as well. Just an easy way to check your answer to make sure you've got the right one. Alright, this next one's not so nice. It's not so nice. We don't have a variable by itself, so we're going to have to do a little bit of work at the beginning. We're going to have to solve for one variable. It really doesn't matter what variable you pick. If you're going to have a fraction, if you have a fraction in your problem, I want you to leave it as a fraction. The only time a decimal is okay is if it is terminating. Here's why. If you round your decimal here, you're not going to get the right answer. You're going to have an answer that's close, but it's not going to be exact. If you have a terminating decimal, it's fine. You should get the right answer, but if you round a repeating decimal, you're not going to get the right answer. You're not going to get the same answer. So, to help us solve, I'm going to go ahead and solve for y in the second equation. I think that would be a good value to solve for. Solve for y in the second equation. We'll start by adding 3x. And we'll divide by 2. I have y equals 3 divided by 2. If you take 3 divided by 2 on your calculator, you're going to get 1.5. That's a terminating decimal. I'm okay with that being a decimal. If it had been repeating, you do need to leave it as a fraction.
Can you just leave it as a fraction?
Yeah. You want to work it as a fraction then? Should we work it as a fraction then?
I don't think I do. I was just asking if you could.
Yes, you could leave it as a fraction and work it. In fact, if it is going to give you a repeating decimal, or a non-terminating decimal, let's leave it as a fraction. 27 divided by 2, I'm okay with that being a decimal because it is terminating. 13.5. Alright, so I'm going to take this equation, now that I've solved for y, I'm going to take 1.5x plus 13.5, and I'm going to substitute it in for y and the opposite equation. Don't put it back into the same equation, put it into the other. Negative 3 times 1.5x. negative 4.5. X, negative 3 times 13.5. Negative 40.5 equals 18. Go ahead and combine like terms here and here. 4x minus 4.5x is negative 0.5x. Add 40.5. $18 plus 40.5, 58.5. Divide by negative 0.5. You get an answer of negative 117. Change it with us. Write this down. Write this down. Okay, so now we need to find y. You can substitute negative 117 into whatever equation you want. This would be an okay equation, this one would be fine, but I'm going to pick this one right here. I've already got y by itself, it's just going to be a matter of plugging in negative 117 for x. So y equals 1.5 and negative 117 plus 13.5.
What?
So 1.5, how do you what? You see where I'm putting it in? You okay where I got the negative 117?
Yeah.
Okay. You can put that answer back into any of the equations. You can put it into this one. You can put it into this one. I'm going to put it into this one. It's the same equation, this equation right here. Y equals 1.5x plus 13.5 is the same as the second one. I just rearranged it in a different order. I'm putting in there because it's just going to be a matter of multiplying and adding. So 1.5 times negative 117 is negative 175.5 plus 13.5 is negative 162. Remember, our answers are always ordered pairs, so we have negative 117 and negative 162. Okay, so here's our next example. I've got two more, this one and one more. So here we have 3x minus 6y equals 6, 2x minus 4y equals 4. We need to pick one variable to solve for. One variable by itself. I think that there are variables, better variables to solve than others. Which equation? That'll work. Solve for x, the second one's a good choice. We'll start by adding 4y. So 2x equals 4 plus 4y. Divide by 2. 4 divided by 2 is 2, and 4y divided by 2 is 2y. So 2 plus 2y is what I'm going to substitute. I'm going to put that into the other equation for x. We do have to distribute the 3, so we have 6 plus 6y minus 6y is 6. 6y's do cancel. So you're left with 6 equals 6. We haven't made a mistake. This is what's going to happen in our equations. The variables are going to cancel out. We're left enough with a true statement, 6 does equal 6. So think about your different possibilities you could have for answers when you graph systems. Our lines may intersect at one point. We may have parallel lines, or we may have the lines that are the same, exact same equation. We know what our answer looks like if we have one point of intersection. If they're parallel, are they ever going to intersect?
No.
So they don't have any solutions, right? So this would be a false statement if there was no solution. This one is true. So we have how many solutions? Infinite solutions. 6 is not our answer. We have infinite solutions. These are actually the same equations, they're just guys. You could simplify them a little bit. They're the same equation. So if it's a true statement when you solve, your variables cancel out, you have a true statement, we're going to say that there's infinite solutions. If it had been a false statement, what do you suspect we're going to say? No solution. So our last one, 6x plus 8y equals negative 16, and 3x plus 4y equals 12. Change, you want to write this one down? It's our last one. So we're going to leave on your notes. We need to pick a variable to solve for. I think maybe you should be careful. You want to solve if you're probably going to have a fraction here. So solve for a variable that's going to give you a terminating decimal. Anybody have a thought? And what's the equation? You solve for x, you're going to have 4/3 as your fraction. Let's solve for y. That way, if we solve for y, we're going to have 3/4, which is a terminating decimal. Solve for 1. It doesn't matter if you use a fraction. That's fine. That's fine. I'm just trying to avoid those repeating decimals. We're going to put this equation 3 minus 3/4 x into the other equation. Eight times 3 is 24. 8 times 3/4 is negative 6. 8 times negative 3/4 x is negative 6x. 6x minus 6x is 0. Does 24 equal negative 16? It does not. So we would say no solution. So we're solving systems of equations by substituting. This is just one way to solve algebraically. I do have some problems for you to try out of your textbook. Page 147, 15 through 23. You guys should start bringing your textbooks with you. I only have 4 textbooks